And welcome to chapter 9. So today we are covering IP addressing, actually the subnetting of IPv4 networks specifically. And then we'll talk briefly about IPv6. There is really no subnetting, but how to configure it and things like that. So let's get started immediately. We'll talk about the questions as we go along. All right. So let's begin. The objective is how to break up the network into multiple smaller networks. So why do you want to subnet? Subnetting is, as you can see, it's the process of segmenting the network into smaller network spaces. So I'll give you an analogy. For example, let's say that we are going to teach our 4 CCNA classes in the same big, huge room, one broadcast domain. That means we are all in the same physical LAN, all 4 classes with 4 different professors. And let's say, obviously, that's going to cause a problem. Now, assuming that we only have one room and it can fit all of us, all 4 classes. Now, problem number one, obviously, if one speaks, everyone has to listen. So if one from CCNA 1 class speaks, everyone has to listen. So now instead of taking the class 1 hour, let's say, now it's going to take 4 hours to finish. So that's traffic problem, number one. Number two, security is an issue. Security is an issue. Let's say somebody, a class in CCNA 4, the professor wants to see something that he doesn't want the rest of the other classes want to communicate, wants to hear it. So that's going to be an issue as well. So security will definitely be an issue. Why? Because they are in the same broadcast domain, in the same LAN. And maintenance and management is difficult because you don't know who's in your class and who's not. Because, assuming that all students can sit in the same place. So what can you do? How do you solve the problem? Assuming you cannot go anywhere else, you're stuck into that room. We have no other choice. The best thing to do, let's assume that the room can accommodate, it has 254 seats. So what do you do to fix this problem? You remove some of the seats and build walls. Subnet, break up the internal classroom into, let's say, 4 classrooms, 4 classrooms. So the first one will be CCNA 1, CCNA 2, CCNA 3, CCNA 4. So CCNA is the network address, and the numbers 1, 2, 3 are your subnet addresses. So now the university doesn't care because they're still giving you the same room. So people from outside, when you subnet your network, they don't see anything that's happening inside. It's only happening inside. Okay, inside the LAN, you break up your network into smaller network. Why do you want to subnet? So you can have control over the traffic, more security, and easier to manage as well, right? So if you have, for example, student, faculty, and administrative LAN, you want them to be on a separate LAN because of those 3 constraints, security, traffic, and really management. Each of those, anybody that is attached to a switch is considered to be its own broadcast domain, and therefore they are in their own LAN, each of those. Okay, so each of those need a network address, a layer 3 address. So in the old days, when you went out and you have to purchase 3, let's say class C addresses and for each one of them. But what you could do now is subnetting, purchase one, and then break up that one IP address into 3 subnet addresses. So this way you can make it a little bit easier. All right, so you can actually read your book and go through the subnetting. They go into the little ones and zeros. I want to use my technique. So what I'm going to do is I'm going to go to the our notes, the notes that I created for this chapter, and go over them. So if you want, and here's what I want you to do for today's homework is I want you to copy the notes. You don't have to do the drawing. Copy the notes and hand them in. All of these notes, copy them and hand them in as your as your homework. Okay? So we'll go over it step by step. So let's say you were given a certain topology right here, a specific topology, where you have two routers and they are connected with a serial port. I just did this quickly on Microsoft Word. And you have four LANs, right? And you went out and you got one IP address, 192.168 with /24. That means /24. That means you can have, there are 8 zeros left over in the host portion of that IP. And therefore 2 to the 8 is 256 minus 2. We got to take away the network address and the broadcast address. So we are left with 254 hosts. So if you have /24 IP address, that means that IP address, you can allow 254 hosts in it. That's just for one LAN. But how many LANs do we have? You have one LAN. By the way, how do you know how many LANs you have? You count the ports on the router. So you have 1, 2, 3, 4, and the link, because they're sharing the two serial ports, that's also another LAN. So you have 5 LANs altogether. That means if you don't do subnetting, you're going to have to purchase 5 different network addresses. Obviously, this is not uh, a global IP address. It's really a private IP. So, but anyway, you would have had to get 5 different IP addresses. So this is how you break up the network. Let's assuming you will purchase only one IP address that accounts for 54 users. The first step you're going to do, we're going to do just regular subnetting and see what is the disadvantage of just doing regular subnetting. And then we'll go in and do variable length subnet masking and see the advantages of that. And that's what everyone really does right now. All routers support VLSM, and that's what you should do. But we'll do that the second half. I just want to go over the first half because there's a very good chance that you may be asked on your tests or on your CCNA exam questions about just regular subnetting and how do you do it. So we're going to do it the quick way. We are not going to get into the ones and zeros. If you want to do that, you can read your book doing that. You can follow this method, my method, and do fine. If you have any questions that comes up and you don't think it could be answered with my methods, please shoot it over, and I'll see what we can do. Anyway, but it's been successful for the past several years. I've been doing this. So here's what you do. You look at the topology and you decide on how many subnets do you need. In this case, as I've said before, you count the number of interfaces on the router, and that will tell you how many subnets. Again, 1, 2, 3, 4, and the link is 5. So after you do that, that means you need 5 subnets. Then you're going to ask yourself, how many bits? You have 8 bits right here. How many bits do I need to borrow? Remember the analogy? How many seats do I have to remove, in other words, from the room to create walls? In other words, here we're asking, how many bits do I borrow from the host portion to create at least 5 subnets? And what you do is you follow the equation 2 to the x has to be greater than or equal to y, where x is the number of bits you have to borrow from the host, and y is how many subnets you need. So I'll write it out here. 2x has to be greater than 5. Greater than or equal to, I should say, not just greater than. Okay? Now, you can do this by trial and error. X equal 1. Is 2 to the 1 greater than or equal to 5? Obviously, no. Try 2. 2 to the 2. Is that greater than or equal to 5? No, because 2 to the 2 is 4. Let's try x equal 3. 2 to the third. Is that greater than or equal to 5? Of course, because 2 to the third is 8. So you have to create 8 subnets, even though you only need 5. Okay, so I have to remove 3 seats. Okay, so next step, this is what you're going to do. You need to find a new subnet mask for those 8 subnets. The old subnet mask is /24, and the way you do it is you take the 3 that you got, add it to the old subnet, the 24, and you get slash 27. So your 8 subnets that you're going to create will have a slash 27 on them. Okay, now what is slash 27 in decimal format? There it is. You can get this. I will cover that in class. Come down here in the chart. Slash 27 is right here. Okay, and each subnet of these 8 will now can accommodate 30 hosts. All right, so that's what that means. All right, getting back here. All right, so how many actual subnets you're going to create? It's you take the 27 minus the 24, the new subnet minus the old. You get the number, and then this number becomes the exponent with the base 2. So 2 to the third equal to 8 subnets. That's how you got to create 8 subnets. If the answer was 1, then it's 2 to the 1. If the answer is 4, then it's 2 to the 4. If the answer is 5, then it's 2 to the 5. That's how many subnets you got to create. Now, once you're going to create 8 subnets, then you got to figure out the number that you're going to add to each one to get the 8 subnets, and that's called the block size. The block size will always equal to 256. It starts with 256. That's because of 2 to the 8. And subtract the last number in the subnet mask, minus 224. Now, if this sum number turns out to be a 0, then you move over and subtract this number. And we'll talk about that when we do the other example. 256, the last number in this case is 224. So 256 minus 224, you get your 32. That's the block size. Now you need to create your 8 subnets. All right, so here they are. The first subnet is always given to you because that's the old IP address, which is right here. Okay, so you write that down, and that's the first thing you do. And obviously, everybody's going to get a slash 27, like I said to you before, right? All 8 will get the slash 27, the same subnet mask. Then you add the block size 32 to the last byte of the address. Why to the last byte and not to any of the other numbers? Here, listen carefully, and I want you to write that down. It's because when you calculated the block size, you used the last number of the subnet mask. The last number of the subnet mask was subtracted from 256. Because you use the last number, you add the 32 to the last number of the subnet address. So 0 plus 32 is 32. Now the block size keep adding. 32 plus 32, you get 64. Plus 32, 96, and then plus 2, 128. I'm sorry, plus 32, then plus 32, 160, plus 130, plus 32, 192, plus 32, 224. And there's your 8 subnets. Okay, with all slash 27s. Each one of those can accommodate 30 hosts. Okay, now you need to get the range of addresses that you can assign to hosts inside each LAN. And the way you do it is the following. The first valid address is you always add a 1 to the last byte of the subnet address. So 0 plus 1 is .1. When I write .1, that means the address is 192.168.10.1, right? To get to the last address, what you do is you look at this address right here, the last address, and then look right underneath it, the last address, and you look right underneath it. Well, if you see a number, you subtract a 2. So 32 minus 2 is 30, and that's your last valid address. So LAN 1, we'll give this to LAN 1. You can give addresses in LAN 1 between .1 to .30, and they have a subnet mask of slash 27. Okay? Let's take a look at LAN 2. Add a 1 to the 32, it's 33. And the last address, it's 64 minus 2. What would be the broadcast address? Add a 1 to the last address, always. Okay? And so on. So there's your 5 subnets, and you have 3 extra. So what you did is you took the classroom and you divided it into 8 little classrooms. and each classroom can have 30 students in it, and you have three classrooms, three small classrooms, three subnets that are not going to be used, maybe for future expansion. Okay, now here is the problem with just doing regular subnetting. Number one, the really two issues with just regular subnetting is that you are limited to 30 hosts per LAN. So what happens if you have a LAN that needs more than 30 hosts? That's too bad. They can't do it. That's their limitation, right? In this case. And here the link, by the way, the link doesn't need more than two hosts. He has one here and one there, and there's nobody else on this wire, right? So therefore, you are forced to assign a whole network, a whole subnet that can accommodate 30 hosts to a link. So you're wasting what? 28 addresses. So a waste of wasteful IP addresses, and you are limited to how many hosts per subnet you can do. Okay. Now what we do is we move on to VLSM. VLSM, well, variable length subnet masking. I wrote a chart out for you right here to make it a little bit easier to remember. And here's what you need to know. If you see these slashes, these are subnet mask addresses that can be written in decimal format. If you increase the subnet, the slash number, right? This slash number tells you how many bits are in the network address, right? So you have slash 18, slash 19, slash 20. The bigger the subnet mask, the bigger the slash number, the less hosts are going to be left over. For example, if you have slash 18, how many bits are left over to get to 32? The bits that are left over are the bits for the hosts, right? Because slash 18 tells you the network portion of the IP, that how many bits are in the network portion. So if you have slash 18, and how many bits are left over to get to 32? 12, right? Actually, 14. So 2 to the 14 gives you 16,342. Let's say if you have 20, how many bits are left over? 12. 2 to the 12 minus 2. Don't forget the minus 2. Gives you 4,094 hosts, and so on. So, as we will be discussing later, as you vary the length of the subnet mask, you can get less or more hosts per subnet. That will automatically solve or take care of the issues that regular subnetting give. You know, you're limited to the number of hosts. So now I can really give them each subnet depending on how many how many hosts they want. And when you have a link, you always give it a slash 30 because they only can offer two. So you're not wasting any IP addresses. Okay? And in some books they consider VLSM is really subnetting a subnet. Here's how you do it. Let's start with the same topology that we have on the top. Okay, the two routers and two LANs on each. Here's what you do with VLSM. Let's say you are giving an IP address. We'll change the IP address to 192.168.60.0/19. So you gotta have this IP address with /19, and you have 8,190 hosts, and you want to break it up. Let's say you have LAN 1 wants 600 hosts, LAN 2 wants 1,500, LAN 3 wants a maximum of 300, LAN 4 wants a max of 100, and the link obviously only needs 2. Okay, so if there is the requirements now for each LAN, each one of those LANs requires a different number of hosts. So you cannot do regular subnetting in this case. Okay? So here's what you do. The first step you're going to do is you start with the largest number of hosts. That's very important. So find out which LAN needs the most number of hosts. In this case, it's LAN 2. and 1,500 hosts. So what you do, and you say, all right, 1,500 hosts. For 1,500 hosts, which slash do I need? Should I give them slash 22? That would be no good slash 22 because slash 22 only offers you up to 1,022. So you got to do slash 21. Can you give them slash 20? Sure, but it's too much. It'll be wasteful. So slash 21 is the most appropriate for LAN 2 because they're requiring 1,500 hosts. So you write slash 21 and then you write um, the corresponding decimal format. So you write 21 in decimal format and you get that from the chart as well. Okay. Second step, you take the new subnet mask minus the old. The old is the slash 19, right? There it is. So 21 minus 19 is 2. Then 2 to the second, remember this 2 becomes the exponent. You need to create 4 subnets. So the slash 19 is going to be broken down into 4 subnets, and each of those subnet will have a slash 21 on it. Okay? What's the block size? 256 minus the last number in the subnet mask. Now I go to the last number. In this case, it turns out to be a 0. I can't use that. That's not considered to be a 0 in this our method. Method 0 is not a number in our method. Okay, so we go with 256 minus the next one. Next one next to it is 248. Using the third number in the subnet mask to calculate the block size. So 256 minus 248 is equal to 8. So you're going to add this 8 to the third byte of each subnet as we write it down. So the first subnet is 192.168.160.0. That's the first, that's the old one that's given to you, right? And it's going to have slash 21. The next address, the next subnet, you add an 8 again to the third byte. Why to the third byte? Because you used the third byte of the subnet mask address to calculate the block size. So 160 plus 8 is 168. Add another 8, that's 176. Add another 8, that's 184.0. They're all slash 21. Now we need to calculate the range. Let's just go for the first one. You add a 1 to the last byte, that's dot 1. Now, to get to the last valid address in that subnet, what you do is you go underneath and you see a 0. Now, if you see a 0, what you need to do, you cannot subtract the 2. So what you need to do is you need to move over to the guy next to him and you subtract a 1. 168 minus 1 is 167. Now, if you ever did that, you went over and you subtracted a 1, you always write .254 at the end. Is that clear? So in this case, it will be 167.254. So LAN 2 is going to have the range of 192.168.160.1. That's the first address. And the last address is going to be 192.168.167.254. Okay? What's the broadcast address if anyone ever asked you? It's just adding a 1 to the last byte. It will be .255. So here's what we did. We had one big, huge pizza that can accommodate pizza pie that can accommodate slash 19 8,190 guys, right? So what we did, we sliced it up into 4 slices, and each slice can accommodate how many? 2,046. And we took one of the slices and we gave it to LAN 2. So we are left with 3 networks, right? 3 networks left over. And we're giving this to LAN 2. So that slash 19 is no longer used. All right, it's gone because now we have 4 subnets and we took one and we gave it to LAN 2. So we're left over with 3 subnets and 3 slash 21s. Okay? That's it. If you understood this, you really did all your subnet. In fact, once we go through this, you'll see the process repeats. It'll be very easy, and all you need is to have a little bit of practice, and I'll give you a whole bunch of questions to keep doing this. We'll be doing this semester. Every class that we go into, every class, we'll be doing subnetting, and by the time, hopefully, in the middle of next term, if you don't learn it now, because sometimes it's a little bit, if you're new to this, you need a little bit of practice and repetition, 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 and then you'll become a professional at this. You're going to be doing this so fast that it's going to take less time for you to do this with even without a calculator. Never mind going on the internet and Googling the answers. You're going to be doing this so fast in your head that you don't need a calculator or having to go to Google to get some answers. All right, let's continue. Now, the next largest number of hosts is LAN 1, right? They want 600 hosts. So what you do is you take 600. What slash do they need? So you go back to the chart. 600 looks like they need a slash 22, right? Slash 23 is not good enough because slash 21 offers 512. Slash 22 is perfect, right? That will give us 1022. So you go right here and you say slash 22, write that in decimal format, right? Then you take 22 minus 21, that gives you a 1. Then 2 to the 1 gives you 2 subnets. So now I need to take a slash 21. Now, by the way, one of these are going to be the old subnets. That slash 19 is no longer used. So just to be consistent, always use the very next available one, right? Although you can use any of the three. Okay. What's the block size? It's 256 minus 252, right? Because the last byte is 0. And the answer is 4. So what's the first address? The old one, 192.168.0. There it is. And you need to create 2 subnets. And you're adding a 4 to the third byte. Why to the third byte? Because you used the third byte of your Subnet Mask to calculate the block size. So 168 plus 4 gives you 172.0. Both slash 22. What's the first address? Add a 1 to the last byte. So it's .1. What's the last address? I look underneath. I see a 0. I move over. Subtract a 1. 171. And then you always write a .254 at the end. And that's it. That's your range. Okay? Next, that goes for LAN 1. Who's the next largest number of hosts? LAN 3 requires 300 hosts. So I go through the same process. 300 hosts. If you look at the chart, it needs a slash 23. And slash 23 has this in decimal format, right? And then you take 23 minus 22, right? Now, if you need to create more than 2 subnets, then you can use this. You can use 23 minus 21, but this should do it, right? 23 minus 22 should do it. You can go back to here, but why bother? Just keep subnetting this subnet. So what you did, by the way, up here, what we did right here, just to let you know, remember we had 3 slices of the pizza? I took one of the slices and I sliced it into 2. And now I'm going to slice this slice again into 2. That's why sometimes we call VLSM really subnetting a subnet. Keep breaking it down so we can conserve IP addresses. All right, so back to here. 256 minus 254 gives you 2 is the block size. Here is the first address, 172.0. Then you add a 2 to the third byte, right? They're both slash 23. What's the first address? 0 plus 1. And the last address, I look down, I see a 0. I move over. I subtract a 1, so it's 173.254. Done. That's my range for LAN 3. Let's go to LAN 4. LAN 4 requires 100 hosts. Now pay attention, there's a little bit of variation here. Now 100 requires 100 hosts. You're going to need a slash 25. And slash 25 has this subnet mask that ends with 128. 25 minus 23 is 2. 2 to the second, I need to create 4 subnets. The block size is 256 minus, you look at the last byte, you see a number, then you use it, right? So 256 minus 128, you equal to 128. So this 128, the answer, you're going to add it to the last byte of each subnet. All right, so here's what you have to be careful with. What's the first address? It's always the 192.168, the last one right here, right? Instead of slash 23, it's going to be slash 25. Now, where do you add the 128, the block size? To the last byte now, because we used the last byte in the subnet mask, right, to calculate the block size. So 0 plus 128 is 128. Now, here's what you have to be careful. When you add 128 to 128, what do you get? 256, right? You cannot write 256 here. That's not allowed. So what you do, if that ever happens to you, you ended up with 256, what you do is you move over to the 174, incremented by 1, it becomes 175.0. So this is equivalent to 256. Okay? And then you add 128 again. And if you have to add 128 again, if you had to, it will be 176.0, then 176, 128, then 177.0, 177, 128, and so on. All right? All slash 25s. What's the first address? Dot 1. And the last one, I look underneath. I see a number now. I don't see a 0. If you see a number, subtract the 2. That's the rule. So 128 minus 2 is 126. Dot 126. And that goes to LAN 4. All right? Now I'm left with 3 slash 25s. See? Now I need the link. Only needs 2 hosts. The link requires a slash 30. 30 minus 25 is 5. And 2 to the 5 is 32 subnets. We're not going to create 32 subnets. The block size is what? 256 minus 252. It's 4, right? Let's write the 32, at least the first few of them. The first 3 I wrote down. Here's the first one with slash 30. And then you add a 2 to the 128, right? And then you add another 2 to the 132, and so on, right? We're just going to take the first one. What's the first address? It's 1 plus 128. You get 129. And the last address, 132 minus 2, which is 130. Now, here's something to remember when you're talking about a link. It's always going to be slash 30, and it's always going to be the first and the second address in the subnet. And that's it. And that's it. You've learned VLSM, and you learned subnetting. There is no way anyone can ask you any questions on how to subnet a network. If you follow this method, you will always get it right. All right? Anyway, now, let's say you create a chart and you want to fill it out. Typically, what we do is we assign the last IP address in the subnet. So, for example, to the default gateway. This is the default gateway right here. And let's say there's a PC attached to this switch. So you give an IP address here, the last IP address, this is line 1, and the first IP address goes to the PC. So going back down here in the chart, router 1 fast Ethernet 00, that's for LAN 1. That's the default gateway. And if you look at LAN 1, where's LAN 1 right here? The last IP address is 192.168.171.254 with slash 22, right? So there's LAN 1. 192.168.171.254 with slash 22 is the subnet mask. Now, does he get a default gateway? No, because he is the default gateway. Fast Ethernet 01 is LAN 2, default gateway. That should be the last IP address of LAN 2. You can check it out on the top. And it's slash 21. Okay? Now let's go to the PC. PCA is attached to LAN 1. He should get the first IP address in the LAN with the same subnet mask, and the default gateway is this guy right here, right? Fast Ethernet 00 of R1. And going back to the chart, PCA gets 192.168.1/22, and the default gateway right here is this guy right here, right? Look at PCB. He gets the first address in that subnet LAN2/21, and the default gateway is Fast Ethernet 01, right? Look at the links. R1 serial 00 gets the dot 129, and R2 serial 00 gets the 130. And they're both /130. Okay? So you don't have to worry about DNS server and any of that other stuff. That's it. I mean, this is what it really comes down to. It's that simple. By the way, you don't have to assign the last IP address in the subnet to the default gateway and the first address to the PC. But in most cases, it's a good practice to do either the first IP address goes to the default gateway or the last IP address in the subnet, although you can use any IP address within that range. I prefer the last IP address because once I give that out, I know what to give the LAN. Now, sometimes they ask you on the exam to give the first IP address in the subnet to the default gateway and then assign the rest to here. A lot of books do that, but that's okay. I mean, either way, it doesn't really matter. It would work fine. Just remember what you gave. It's easier to remember if you give the first or the last than to give something in between, right? All right. Here's what I also want you to do. Once you wrote out all the notes, all right, that's what you want to submit for homework. Then I want you to see if you can build this in Packet Tracer, right? And this guy is a DCE, by the way, right here. I'm going to write this down, which means you have to put a clock rate on it. Okay. And this is extra credit. See what you can do. And let's see if you can do this configuration. Okay. By the way, if you do all this and everything worked out fine, um, you are not going to be able to ping somebody from LAN 1 into LAN 3 or LAN 2 into LAN 4 going across. That's because you don't have routing between them. See if you can do static routing. That is covered in 205 class, in the next class. But so don't bother ping. But LAN 1 and LAN 2, they should be able to ping each other. LAN 3 and LAN 4 should be able to ping each other as well. All right. So again, this is for the subnetting, and you can whenever you're doing any of your exercises, come back and refer to this. Again, I really don't want to give you this. I want you to write this down on your notes and submit it as homework. All right. So that's one of the reasons I'm not really loading this up, and I'm not even loading any of my notes in the doc sharing because I really want you to take notes while you listening to this. Okay. All right. So let's go back to the slides and see. I think we covered almost everything in the slides. So here, your book goes in a little bit. This is the regular subnetting. This is where they borrow. This is where they're breaking up the network. Okay. So let me they use the same formula that we use. Just follow. I don't want to go over this because we went over our method. You can really take this step by step if you wanted to do this. So this is something similar to what we did, right? /27. Wow, pretty good. So you can actually do something like this. This is you're starting out with 192.168.1.0/24. Just do regular subnetting. See if you can do this. 1.0. We did what? 10.0. It's exactly the same problem we had for the regular subnetting, not the VLSM. All right. So here we can do the subnetting to meet the network requirement. This is where we're getting into VLSM, subnetting a subnet. And, as you can see, With borrowing bits, it becomes a pain. So that's why I like to do it my way. Well, it's not my way. I've learned it from different books, and then I've come up with just a method so students can learn this very easily. And I don't have any student once they practice this over and over, no one has any issues with it. By the time we get in the middle of 205, no one in my classes, no matter how weak you are, you will know subnetting. So that's not going to be an issue. Anyway, when we get into IPv6, you're not going to do a lot of there's no subnetting at all, in fact, right? All right, so this is configuring the IP addresses. This is like giving the first IP address to the default gateway. All right, but as you can see, they're not typing no shut. That's not good. They have to activate the interface, right? If they want that to work on the fast Ethernet and on the serial ports. So we can actually see something. This is from my chart that I gave you. It's probably a little bit easier. Okay. So how do you plan for the IP? Get the range addresses like we did. So we can set up the range addresses. For IPv6, all you have to do, you already got your subnet ID right here. Those 16 bits, like we said. So you can start with, you got your 48 bits already given to you, the global routing prefix. Then you can say subnet 0 goes to the student. Then you put a 1 right here that goes to the faculty. Everything else is the same. 2 is for the administration, 3 for someone else, right? And so on, right? That's it. There is no subnetting required. If you're going to need, these are 16 bits, and 2 to the 16 gives you what? 2 to the 16 is 65,536 subnets. If you are ever going to create more than 65,536 subnets, which I very, very doubt, IPv6 allow you to borrow a bit from the host. But I'll tell you right now, you're never going to do that in your lifetime. You are not going to create 65,536 subnets. You're not going to administer that. That's impossible, right? So there's no subnetting virtually in IPv6, right? All right. So there's your 5 subnets. It's much easier with 6, right? You just go right here and put subnet 1, subnet 2, subnet 3, then take the whole thing with subnet 1 and give it to LAN 1. Put a 2 in here, take the whole thing, give it to LAN 2. And remember, the interface ID, the host, can be generated by itself. The IPv6 is much, much easier to configure. And hopefully, but the thing is, we do need to be able to support both IPv4 and IPv6, at least for the next few years. And maybe 5, 10 years from now, IPv4 will be phased out, and all we're going to be dealing with IPv6. And we'll deal with that later because it's more secured and less cumbersome in terms of assigning IP addresses and so on. All right, so that ends chapter 9. And so far we're doing great. Please, if you are not comfortable, you can always come back and look at this. Of course, you can always read your book, and you should always read your book to find little things that we may not have gone over in class, in the lecture. If you have any questions, please do not hesitate to ask. And don't forget, write all the notes that I had in that Microsoft Word and submit that as the homework. All right. And if you can't really see the text, just click on the block right here while you're seeing it, and it should blow. You should see it much clearer, right? You should be able to zoom in. All right. Until we meet again in chapter 10. God bless.